From Fox 35 Mission Control, an out-of-this-world discovery. NASA says it just found a new planet.
Shocking, right? Yeah, the James Webb telescope spotted it just outside of our solar system.
Striking infrared images were taken this summer by the James Webb Space Telescope.
From the silent vastness of the Orion constellation, a cosmic puzzle has surfaced. One so cold, so hidden, and so confounding that even the world's top astronomers are questioning the known boundaries of planetary science. The James Webb Space Telescope, humanity's most powerful eye on the cosmos, has set its sights on the dark lanes of Orion. Here, Webb has uncovered not another faint amber distant star, but something wholly unexpected, a world whose chilled mystery and elusive presence demand a rethinking of what is possible in the architecture of planetary systems. When the initial Webb images rolled in, nothing immediately stood out. The data painted familiar scenes of dust, the luminous processes of star birth and death, and the drifting clouds of hydrogen and carbon. But as astronomers passed through the subtle patterns and shadows hidden within this nebula display, something strange kept cropping up. A dim, anomalous object, a cold, dark world, began to hint at its presence, distinguishable largely by its lack of warmth amid the backdrop of Orion's activity. This ghost planet, as it has drawn the team's imagination, does not match the expected signatures of exoplanets. Its very existence seemed to challenge the prevailing understanding of how and where cold worlds settle in star-forming regions. It is as if a frigid, invisible entity was purposefully eluding both detection and explanation, threading the boundaries between what is seen and what is suspected. A planet colder than nearly anything previously imaged, inhabiting a realm characterized by the chaos of solar creation. And yet, when pursued for confirmation, this world seemed to do the unimaginable. It vanished from view, returning only under the most sensitive scrutiny from Webb's unblinking gaze. Is this truly a rogue world, ejected from its birthplace, or could we be seeing a new class of cosmic phenomenon, one that bends both observation and interpretation? Could Orion, a constellation so familiar in the night sky, have hidden such a secret in plain sight, awaiting only the reach of our newest, most ambitious telescope? Echoes from the cold frontier. The first indication arrived not with a dramatic flash, but rather a hushed silence, a record coldness in a place where energy abounds. As Webb mapped the bustling star nurseries of Orion, zooming in on dense clusters of nascent suns, an oddity began to emerge. The telescope's instruments, designed to separate the feeble heat of planets from the ferocious furnace of star and nebula formation, detected a faint, blue-tinged signature. It was clearly not a star, and yet its coldness was unmistakable. In August 2024, Webb's direct imaging captured what appeared to be a cold world in extraordinary detail, so faint that it revealed itself only under the deepest, most prolonged exposures. The planet radiated almost no heat and registered in the infrared almost by the blankness it carved out amongst the energetic backdrop. Its observed temperature was measured below that of Neptune, positioning it among the coldest exoplanets ever observed, and defied prevailing models of planetary form and placement. The implications were immediate. Worlds this cold are expected to cling to the distant outskirts of mature solar systems or roam as cosmic orphans between the stars. But here was a cold planet residing within one of the most active, tumultuous regions of star formation. The prevailing thinking, whereby such frigid objects should either be isolated or drifting, could not easily accommodate this planet's existence near the bustling, youthful population of Orion. How did such a chilly and ancient-seeming world form, persist, and withstand the tempests of a stellar nursery? The models faltered. None could convincingly reproduce the planet's spectral qualities or its starkly low temperature. Thermographic scans suggested a chemical makeup more akin to leftover material from planetary formation, methane, water, perhaps even frozen carbon molecules, than to anything yet known among Orion's planets. Debate ensued. Could this planet be the scarred survivor of a violent planetary past, flung outward by interactions with neighbors? Was it perhaps gravitationally ensnared by the dense milieu of Orion, left adrift and frozen? Or was it the outcome of an even stranger process, one that made it a cosmological relic, preserved in icy stasis through cosmic upheaval? What secrets might such a frozen ghost truly hold? If you're fascinated by mysteries like this, make sure to subscribe so you don't miss the next chapter. Now let's move on to what happened when this world seemed to vanish altogether. The Disappearing Act. As the months passed from January to April 2025, the Webb team persisted, directing their observations again and again at the region where the cold ghost had appeared. But the results confounded expectations. Every new round of imaging returned empty. The planet that once registered so clearly now faded into the background. Lisa Chatterjee, a lead data scientist with the Webb mission, succinctly described the situation. "We lost it. It was there, and then it wasn't." The team rigorously audited their data pipelines, checked for instrument irregularities, and scanned for possible contamination, but the conclusion remained inescapable. The object could not be detected in follow-up scans. Planets do not simply vanish. Orbital mechanics would predict their whereabouts or explain temporary disappearances due to eclipses or dust cover. But here, no such reasoning fit the data. The planet's signature had not merely dimmed, it had evaporated, and yet just as abruptly, it returned in later datasets, bearing a spectral fingerprint nearly identical to the original, but shifted ever so slightly in position. Each appearance and disappearance forced astronomers to re-evaluate ideas about planetary evolution, orbital stability, and the limits of thermal detection. No known mechanism could completely account for such behavior. While rogue planets sometimes traverse crowded regions, their passage is typically marked by detectable gravitational effects. Here, the silence was total. No gravitational disturbance, no brightening or dimming of local starlight, no dust cloud casting shadows. Could the planet somehow exist on the margin of detectability, only visible under certain alignments of telescope and cosmic dust? Or did its emergence point to a phenomenon at the edge of astrophysical understanding, a transient, perhaps lensing-driven apparition? Analysis and persistence eventually confirmed that though the planet's signature was tenuous, it was real. Each time Webb peered into Orion, the world's presence seemed contingent, elusive, defying every expectation for what should be observable and when. The blueprint of a ghost. Refusing to yield to this mystery, the Webb team pushed their spectrographs to the maximum. Each observation strove for increased sensitivity, painstakingly cataloging photons, hoping to reveal something new about the cold world's chemical makeup and structure. These deeper looks confirmed the extreme nature of the planet's coolness as much more than an artifact or a simple result of distance. The planet's atmosphere, if it warranted that term, showed evidence of molecular hydrogen under immense pressure, enough so that, At these temperatures, condensation should have been inevitable. Methane, a staple of the outer solar system's giants, was also detected, but its spectral profile suggested it was present in far greater purity and at lower temperatures than ever seen around other exoplanets. Perhaps most intriguingly, Webb's sensitivity allowed the team to record the first unambiguous detection in space of a particular carbon-based molecule long theorized to be crucial to prebiotic chemistry. While not proof of life or even a hint of biological activity, this compound's presence in the chilly deep freeze of a cold world hints at chemical processes preserved by extreme cold rather than erased by dynamism and heat. It supports the view of such places as archives of the earliest organic chemistry, potentially holding the story of planetary beginnings. Even the planet's emission spectrum was unique. Instead of radiating as a simple cooling body, it gave off energy in sharply defined bands, implying an equilibrium distinct from that of typical planetary cooling. Instead of being warmed from within or blasted by radiation from nearby stars, it was, in effect, radiating away the last vestiges of its primordial heat. A slow, steady, gemstone-like cooling, perhaps untouched by stellar activity for eons. Some hypotheses suggested this might be a planetary core, stripped bare by ancient violence, a fragment left behind as larger systems shifted and changed. Others speculated it could be the product of rare gravitational interactions, its path through Orion a testament to cosmic accidents on unimaginable timescales. A new kind of planetary dance. Yet the strangest features emerged only as scientists tracked the object's movement. Unlike most known exoplanets, which parade around their stars in well-modeled orbits, the cold world's path was erratic, not easily mapped onto any expected gravitational relationship. In some datasets, it seemed to move in strange fits and starts, its position shifting in ways not consistent with simple orbital motion. A careful review suggested that its detectability was tied to some extent to the configuration of dust and gas along Webb's line of sight. In moments when dense nebular clouds moved between the planet and telescope, its trace vanished altogether. When the clouds thinned or shifted, the planet reappeared, though rarely exactly where it was last seen. Such behavior brings to mind the phenomenon of gravitational lensing, where intervening mass warps the light from more distant objects, creating brief windows of clarity. Alternatively, the planet's true orbit might be inclined at a dramatic tilt, the result of past planetary close encounters or the ruins of destroyed neighbors. Its unusual journey could mark it as an extreme example of the dynamical violence that sometimes shatters and reshapes planetary systems. It is not alone in this category. Webb has recently imaged cold exoplanets in wildly tilted orbits, such as 14 Hercules C, which shows signs of having been shaped by planetary upheaval. These discoveries raise the possibility that the Orion ghost world is a member of a forgotten class of ancient, cold, and barely visible planets, cosmic hermits whose very marginality hints at a turbulent history. The scars of planetary violence can engrave records more durable than light. A chilling case of missing evidence. Despite the excitement, Webb's data has forced scientific humility. Repeated attempts to confirm the planet's presence across February, April, and beyond yielded results that were inconsistent. At times, the world re-emerged, its spectral lines confirming molecules and temperatures, only to recede again in subsequent exposures. The dependence on Webb's unique sensitivity in the infrared and its ability to segregate faint planetary heat from the nebula raw meant that no other contemporary telescope could rival these findings. Attempts to corroborate the sighting with ground-based or past missions ended without success. Webb alone seemed able to capture the planet at the threshold of visibility. This situation has bred both frustration and fascination. Early announcements of discovery were tempered by caution, and the data has incited debate within the astronomical community. Is the cold world's elusiveness a byproduct of cosmic chance, a planet appearing only when dust, angle, and starlight align just so? Or is it a true inhabitant of Orion, existing on the margins of our observational ability, poised between presence and absence? Theories abound. Could a swarm of rogue planets, born in the chaos of planetary formation, populate the cold gaps between stars, seen only when special circumstances make detection possible? Or is Webb's detection a fleeting mirage, the result of interstellar shadows or complex lensing that briefly mimic the temperature signature of a real planet? For now, only one thing is clear. The Orion cold world remains among the most enigmatic objects yet glimpsed by human technology, its nature revealed only in fragments and moments. The lure of the carbon ghost. While Webb's intermittent glimpses of the cold world constitute one of the most puzzling planetary stories in recent memory, another discovery in the same region holds promise for planetary science and astrobiology alike. Using its advanced spectroscopic capabilities, Webb detected the first instance of a certain carbon molecule in space, one long suspected to be a key ingredient in the formation of life's chemistry. This molecule, notoriously elusive and reactive, had until now only been theorized in the cold reaches of space based on indirect evidence. Its identification in the vicinity of the ghost planet establishes Orion as a region brimming with the fundamental compounds from which planets, and possibly life, can arise. This is not evidence of life, but it is a profound sign of the molecular fertility of star-forming regions and the potential for planets seeded in them to harbor compelling and complex chemistries. It supports the idea, once considered marginal, that the universe's coldest, quietest cradles may shelter the raw materials of planetary building over unimaginably long timescales. It also cements Webb's value as a chemical cartographer, capable not only of mapping the positions of planets, but of decoding the primordial dust and gas clouds from which they form. The cold world, bound up in this spectral web of carbon compounds, could represent a cosmic time capsule, preserving a record of conditions unaltered since the earliest days of planetary history. The butterfly in the nebula. While attention focuses on the cold world, the broader landscape of Orion has also come into sharper view. Webb's imaging of the Butterfly Nebula, a showcase of both cool gemstones and fiery grime, offers a dramatic context for the planet's story. Here, the juxtaposition of diamond-dense dust and incandescent ionized gas reveals the extremes of chemistry and temperature that shape evolving star systems. The cold world perches at the edges of this spectacle, a place where neither the hottest stars nor the densest clumps of dust reign unchecked. Spectral mapping shows regions within the nebula where temperatures drop low enough for molecules to condense and persist, potential abodes for yet more clandestine planets. These observations suggest that the planet's strangeness may not be a solitary aberration. Instead, it might be the first recognized member of a category that is, as yet, only dimly understood. Old, cold, and hidden worlds that survive by virtue of their obscurity. Webb's record of exoplanets in tilted and eccentric orbits, as in the 14 Hercules system, hints that planetary violence leaves behind a long legacy of survivors, each one unpredictable and challenging to detect. It is a sobering reminder that our planetary census is incomplete, and that every dramatic discovery may signal the existence of many more cases hidden behind veils of dust and confusion. Watching the Watchers. News of the cold world's intermittent vanishing and reappearance has reverberated across the global astronomy community, catalyzing collaborative surveys and theoretical introspection alike. Teams have organized repeated observations, scouring both new and archival data in a quest for consistency. Each cycle of appearance and disappearance sharpens the question: does our discovery reflect the universe, or our tools and attention? This is not a case where more data has brought closure. Instead, it has unfolded new uncertainties, inviting debate about fundamental limits on both astronomy and the philosophy of observation. Some suggest that the ghost planet might be a fleeting alignment, an echo of gravitational lensing, or the chance imposition of interstellar dust mimicking planetary cold. Others argue that we are seeing and losing a real planet whose rarity and properties expose the limits of current observation. The phenomenon serves as a lesson in scientific humility. Webb's groundbreaking sensitivity, an asset beyond compare, has revealed a world whose very visibility seems to fluctuate with the circumstances of cosmic geometry and human focus. A mirror held to the cosmos. In the end, the partial discovery of Orion's cold world may be more about what it reveals of our own limitations than about the object itself. The universe, it seems, shields some of its secrets behind veils of ice and silence, raising the philosophical question: can we claim to know something that appears only at the edge of our vision? Is the ghost world a warning that cosmic complexity exceeds the most careful catalogues and models? Is it a prompt to refine our tools and methods, to look deeper, linger longer, and accept ambiguity as an integral part of scientific progress? Or does it underscore the risk of mistaking transients and artifacts for new reality, particularly in the era of breathtakingly sensitive telescopes? Each Webb observation has the potential to reset expectations. The cold world's dance, its fleeting evidence, the molecules it incubates, the questions it raises, challenges the boundaries of certainty and invigorates the search for a more nuanced science. If, in the depths of Orion, a planet can flicker in and out of sight, one must ask, what else have we missed, and what might still await discovery in regions yet unexamined? The minds at Webb, and indeed at every observatory, are now attuned to the possibility that some worlds may be known only in part, glimpsed as echoes, hints, and cold traces in the infinity of space. It is a humbling realization, and a call to continue the quest, methodically, collaboratively, and with the humility befitting the universe's depths. In Orion's night, as in our own, discovery remains a process of pursuit, patience, and the occasional embrace of uncertainty. The ghost planet stands as testament that astronomy's real frontier is often not the objects themselves, but how and when we manage to see them. If you find this chilly riddle as captivating as we do, stay tuned for further updates as James Webb and allied observatories unveil the next clues from Orion and beyond. For in the interplay of heat and cold, light and shadow, even the coldest of ghostly worlds reminds us that the cosmos always holds more surprises than we know, and more truth than we can imagine.